with these trig identity problems. These are proof problems right here. On a free response problem, we give you the full thing. We just say prove it, and then you show all your work and you prove it. On a multiple choice situation, I could take the answer away and just say simplify, and you do the same exact thing, and that's going to be our answer right there. Okay, so let's just practice these 4 problems. I'm telling you, if you know how to do these 4 problems there, you're going to be perfectly fine for the ones on the final. So let me just show my working answers for the first 2, and then let me slide that up. Let me show my working answers for the next 2. And then as we're working out these problems, I have included those Pythagorean identities right there. So you might want to jot those down for yourself there. We're using those throughout this problem, in addition to the normal tangent and sine over cosine, stuff like that. Let's do 2 of these together from scratch, and then we'll just talk through a couple of the other ones, all right? When you have 2 fractions that you're adding and subtracting, you know since your elementary school days that you need to get a common denominator, right? So when they look different like that, what we're going to do, we're going to smush those together, use that as our common denominator, and then you're going to put the new stuff up here. So with this cotangent square, with this fraction from here to here, you already have the 1 plus sine of x. You're missing the 1 minus sine of x. You got to put that on like on the top and the bottom. So I'm going to squeeze that right there. And then with this fraction here, I'm going to carry down that cotangent squared. And then when you go from this fraction to this fraction, you're just putting the new stuff right here. So you already have the 1 minus sine of x on there. You're missing the 1 plus sine of x. It's like you're squeezing that in on the top and the bottom like that. All right, and so let's just simplify this the rest of the way. You can't start crossing stuff out. 1, you're gonna go in one big circle, and then 2, you got that plus sign right there where you're not allowed to do legal canceling like that. So I fault there. So all I'm going to do, I'm going to distribute and clear out the parentheses. So I'm going to take this cotangent squared and distribute that. So I get cotangent squared times sine of x. And then we got cotangent times 1. And then a cotangent squared times sine of x. So we got cotangent squared times sine of x. So you're just going to distribute, clear out your parentheses. On the bottom part, whenever you have the same thing, 1's a plus, 1's a minus, you are going to need to multiply that through. So 1 times 1 is 1, and then you're going to get a negative sign and a positive sign that cancel out. So I'm not even going to bother writing that. And then you have sine times sine, which is sine squared. You also have a positive times a negative, which is a negative. So you have 1 minus sine squared on that bottom. Now, I know these things were weird. You're writing cotangent squared times sine of x. If these ever don't cancel out, then I'm going to convert the sines and cosines. But luckily on this example, at least I have a negative one of those funky things and a positive one of those funky things. So it's just like you have a negative 1x plus 1x. Boom, those are gone, eliminated. Okay. And then what you have left when you combine like terms, you got a one of them there, 1 plus 1, 1 cotangent squared plus another cotangent squared is going to be 2 cotangent squared. And then 1 minus sine squared. What you want to do is change it from a binomial to a monomial. And so you're using your Pythagorean identities. So if I got a 1 minus sine squared, I'm going to move that sine squared over to create the 1 minus sine squared. But what I'm left with, that's equivalent to a cosine squared. So I can make that a cosine squared on the bottom. You guys are so good at these earlier on in the year when we first did those. I was really happy with how those tests turned out. You guys took some of the tougher looking problems and you knock those out, but you're all solid with your algebra too. So all you're doing is common denominators, distributing, using your Pythagorean identities. And now when you get the single thing, you're converting everything to sines and cosines. So remember, tangent is sine over cosine. So cotangent is cosine over sine. If it's squared, the 2 is just going to stay there. And then the cotangent squared, I'm going to make that cosine squared over sine squared. And then you're dividing it by that cosine squared over 1. Now see how you have 2 fractions? This is going back to your elementary school days, that when you have 2 fractions, all you're going to do is multiply by the reciprocal of the second one. So leave the first one alone, and then you multiply by the reciprocal of that second one. And then the cosine squares cancel out. You're left with 2 over sine squared. And then 2 over sine squared is the same thing as 2 cosecant squared, because the reciprocal of sine is cosecant. And then you get that 2 cosecant squared. And that's nice because that's what we were trying to show right there. So on a simplified problem, we'll just give you the fraction and you work it all the way down to where you can't go any further. And then you can just stop right there. All right. And if we make a multiple choice, that'll be there. And on a proof free response for future years there, we'll give you the whole thing. and you just got to do all your work there. But we can be perfect with that. These really aren't that bad. They look worse than they actually are. And then let's go ahead. Let's just do one more from scratch there. This is one where the weird stuff doesn't cancel out, and we got cosecant stuff on the bottom. So I figure it'd be good to talk about that there. So same thing. If I just ignore that answer, I just tell you to simplify that, we're going to get that answer. And we're just going to do some legal algebra here. So I'm going to subtract the fractions, which means I'm going to smush those together, just create my common denominator. And then on the top part, you got that cosine. Remember, match up the new stuff. So you already got the 1 minus. The new stuff is the 1 plus. So you squeeze that in right there. And then you got that minus carries down. That cosine is going to carry down. And then match up the new stuff. So you already got the 1 plus, but you're missing that 1 minus. So squeeze that in there. And I'm going to distribute the stuff out on the top. So cosine times 1 is cosine. And then I get plus cosine times cosecant. That looks a little weird, but I'm hoping, the last one it canceled out, so I didn't have to worry about it. So let's just see what happens. That's going to leave that as cosine times cosecant for now. And in here, be careful with your signs. You have a negative cosine I want you to distribute. So negative cosine times 1 is a negative cosine. And then you're going to go negative times a negative, which is a positive. You have cosine times cosecant. So cosine times cosecant, like that. So there's our numerator. Now on the bottom, you got a plus and a minus. You're going to need to multiply that out. So you're going to get a 1. You're going to get a positive cosecant, negative cosecant that cancel. And then negative times a positive is a negative. Cosecant times cosecant is a cosecant squared. Now this one, here I have a positive cosine and a negative cosine. So the normal things cancel out. The weirder things do not cancel out. So when the weirder things don't cancel out, I'm still going to combine like terms. So you have one of them there, one of them there. So you still have 2 times this cosine cosecant. And then on the bottom part, we got this 1 minus cosecant squared. So what we're expected to have down is those Pythagorean identities. And if I'm trying to get a 1 minus cosecant squared in the problem, I'm going to look at this bottom one where we know 1 plus cotangent squared equals cosecant squared. I'm going to need to create 1 minus cosecant squared. So I need to subtract cosecant squared over. That will give me 1 minus cosecant squared. But if I move the cosecant squared over there to get the 1 minus cosecant squared, I got to subtract the cotangent squared over. So that would be equal to a negative cotangent squared. So 1 minus cosecant squared is equivalent to a negative cosecant squared x. Now there's 2 ways that we can finish this the rest of the way here. Since I got this negative cosecant squared, hold on, my bad. I apologize. I got 1 minus cosecant squared. I'm stupid. You got a negative cotangent squared. This should be, let me rewrite that. So we have a 2 cosine of x. I don't want to rework this whole video though, so I've been making videos all day. And on the bottom, you have a negative cotangent squared. So if I do that again, so negative 1 minus cosecant squared, I move the cosecant squared over there, move the cotangent squared over there. So 1 minus cosecant squared was equivalent to negative cotangent squared. Now, right here, I have way too many trig functions. So all I'm going to do now is convert everything to sines and cosines. There's actually 2 ways that you can go about this, but I'm going to make this 2 cosine of x. And then the cosecant is the same thing as 1 over sine of x. So I'm just going to stick that sine of x on the bottom. So that's like just this top part right there. I got cosine times 1 over sine. So just smush that. You got cosine over sine. Now on the bottom, you have this negative. That's like a negative 1 if you want to put that there. And then cotangent squared is cosine squared over sine squared. And then just like the other one, you have 2 fractions that you're dividing. So multiply by the reciprocal. So I got this. First of all, I know 2 divided by a negative 1 is going to be a negative 2. So I ain't even worried about the number part anymore. But I'm going to leave the top fraction alone. And then we're going to multiply by the reciprocal of the bottom fraction. And then what cancels out here? So here I have this sine of x cancels out with one of those. This cosine of x cancels out with one of those. So I have negative 2. What I have left is a sine of x over a cosine of x. And then you're supposed to know that sine over cosine is equal to tangent. And that's what it is that we were trying to show. So there's our answer. Remember, on a proof problem, on a free response for future years, that's all your work is your answer. You got to show clear steps. We got to be able to follow along every single step right there. For this multiple choice here, though, you're just going to get that answer right there. Now, another way that you could finish that at the end, going to this step here, if you notice that this was a cosine over sine, if you notice that that was a cotangent right away, you could have left the negative cotangent squared on the bottom. And then if you have cotangent over cotangent squared, those would have canceled out. You would have had -2 over cotangent, but also would have switched to the -2 tangent of x right there, all right? So try all those on your own. Try letter A and letter C on your own. I think those are all pretty much the same kind of thing going on. This is very similar to the ones that we just got done doing right there, okay? So I'm taking a quick look. I don't see anything different. Just when you get to this 1 minus secant squared, 1 minus secant squared, the reason I got that negative tangent squared is because when you do 1 minus secant squared right here, when you move that secant squared over, you're also going to move the tangent squared over. So since it's positive, you're going to subtract it over. So 1 minus secant squared is negative tangent squared. So just be careful how you're manipulating those things and being careful with your signs. But all that is algebra based. You guys are all good with your algebra. You're solid with your fraction stuff. You're distributing your sines and cosines, and you're just dividing fractions. I remember when we tested over this earlier in the year, we rocked the hardest problems that was on that test just like this. So we just got to do that one more time. So please, if you could handle all 4 of those and practice all those, you're going to be perfectly fine for this final exam there. So good luck with